launched. It reaches a maximum height of 90 meters and lands 50 meters away, and we're looking for the initial velocity and angle. So first of all, take a moment, put anything that you can in your chart right now. Meters. Meters means this is a what? Distance. And is this an X or Y distance? Y, and how do we know? Because it's height, that's up and down. Good. And landing 50 meters away, that would be what? X what? Distance, yeah. Alright, what else can I put in this chart? The acceleration, as long as we are on Earth, the acceleration is negative 9.8. And anything else? VF for X or Y? For Y is going to be what? When? At the top. Now this is always true, whether it's useful, depends. Would it be useful here? Yes, why would it be useful here? Maximum height. So maximum height is at the top, so this goes with this. Make sense? Is that not what you said? Okay. A, what is A asking for?
You started class already?
Yeah.
Okay.
Thanks for the interruption. Bye. What is A asking for? He got really mad when I interrupted his advisory yesterday. That's why I said that. Because I interrupted his advisory and he was like, get out! Oh my God. Okay. Back on track. A, what is A asking for?
Hello.
What is A asking for? Initial velocity for what? Vertical. Vertical. That's definitely. Alright, refocus, guys. So that is the initial velocity for Y. Do I have enough information to find that right now? Trick question. I asked that in a way that led you to say no, but we definitely do. What equation can we use? There's two equations to start with VF. Which one is it? VF equals VI plus AT or the VF squared equation? VF squared. Why that one? Good, because we have the distance. So you're going to go ahead and plug in, find the initial velocity, VI. If you need help solving it, call me over. What was VF? VF, when we're plugging in, what was VF? 0. VI is what I'm looking for. And which distance would I use, 50 or 90? 90, because we're plugging into a Y equation. We only use X or Y. In this case, we're using Y, so don't mix and match. You can just put this in your calculator. You get the 1776. And now looking at this, what would I do next to solve this? Add this over, so then I get 1776 equals VI squared. Is that my initial velocity? That is the square, so I need to do the opposite, square root. And what'd you get for initial velocity? 42? Is it 1776? It's 1176, right?
No.
It's 1776.
64.
Okay. I'm looking at my answer key. I have like totally wrong. Not totally wrong, but it's a tiny bit off. 2 times 9.8 times 90. Yeah, it's 1764. When you take the square root of that, you get 42. Okay, cool. Now, is that for x, y, or total? That is specifically in the y direction, right? We used all y numbers to find that, so we're going to put that in for VIY. Now, B is asking us to find the time in the air. What equation do you think we could use to find the time in the air? Yep, so VF equals VI plus AT because we have both of these velocities. We have A, and we are looking for time, so plug in, find the time that's in the air. So here I would subtract the 42 over, divide, that would give me T is what? 4.28, is that what it asked for? No, which time is this? That's the time up, the time until it hits the top, because we use the VF is 0, and that's at the top. So what would I do to find the total time? Times 2, and you get what? 8.56? We good with this? Alright, cool. And it's not that the TF isn't useful, that will be useful maybe perhaps later on, but right now we just want the total time. C is asking us to find initial horizontal velocity. Horizontal is talking about what? X. I want to know the initial velocity for X. Normally, if we wanted an initial velocity for X, we would use VI cosine, but I don't know the angle, and also I don't know the initial velocity in total. What else could I use to find initial horizontal velocity? B equals the over T, because we have the distance. Which time would I use? TF or T total? Total, because that is how far away it is when it lands. So that's the total time it's in the air. Good. Plug in. Get your time. Not your time, your V. That's you. What are you guys getting for your initial velocity for X? 5.84? Perfect. Good. So we have the initial velocity for Y, we have the total time and the T up. We've got that our X velocity is 5.84. Now that is the initial X velocity and the any X velocity, because what do you know about X velocities? It's constant. So that is the X velocity literally at any time. Is it the 42 meters per second going to be constant? No, this is at the very, very beginning. What happens to it on its way up? It slows down until it's 0 at the top, and then it is negative and getting faster. Alright, so D is asking to find the total initial velocity. How do we find total velocity? Pythagorean theorem. Good. So if it is going over to the side in the x direction at 5.84, and it's going up at 42, to find the total, you just do the x squared plus the y squared, and that gives me my total squared. So vx squared plus vy squared, where a and b, right, a squared plus b squared equals c squared, a and b are your x and y, and then the hypotenuse is your total. So now you're plugging in, finding the total velocity at the beginning, using the x and the y velocities at the beginning. What are you guys getting for the total velocity?
42.4.
42.4?
Yeah.
Okay. I had 42 point something else, but close enough. 42.4, good. And then a quick check for yourself is that your hypotenuse should always be at least a little bit bigger than the sides, which it is, right? It's bigger than 5, it's bigger than 42. Now E is asking the angle that it's launched at. So if I'm asking for angle, that means that I have to use one of what? The VIX cosine, VIY sine, right? You have to have something with an angle in it. So I'm going to use, let's go ahead and write both of them. You can actually use either one. We have enough information, and I'm going to show you that you get the exact same answer. Now let's pick the cosine one for right now. I want you to plug in your VIX and your VI. The only unknown that you have is the angle. So plug in what VIX is and what VI is. So what number would you plug in for VIX? What is your initial velocity in the x direction? 5.84, right? We literally answered the initial velocity, horizontal velocity. We said it was that. And what would the VI be? What number would that be? Yes, the 42.4. Good. So that is the total initial velocity. So you'll notice that the equation, right? These are both initial velocities. One is in the x direction. This is in the y direction. The VI is like the total for both x and y. And then we've got cosine of the angle. So now we're trying to get the angle by itself. 42.4 is in the way. So what should we do with it? Divide. Good. So divide 42.4 over. So we have 5.84 divided by the 42.4, and that gives us 0.137, something like that. Now here's where it's probably been a while since you've had to do this. We can't just divide by cosine, right? You can't. If you hit divide cos in your calculator, you're going to get error. So anyone remember how we undo a cosine? The second cosine. Yep, so second cosine, it puts this like -1, it means inverse. So the inverse cosine of 0.137. So I want to see everyone do this in your calculator. So we have 0.137 as cosine of the angle. So we do second cosine, because that'll do inverse cosine. And we put the 0.137 in. And what are you getting? 82 point something? Good. I'll just leave it as 82.1. Yep, to undo cosine, you do second cosine. Now let's practice using the sine equation. We should get the exact same angle, so I want you guys to plug in right here, VIY, VI, looking for the angle again. So, not necessary, but I'm just showing you that it'll work for the second one. What would we plug in on the VIY? What number? 42, because that was the initial velocity for y. What would we plug in for VI? 0.4. Good. Now, in order to solve this, what would I do first? Divide it over. So you guys should be doing this in your calculator now. Divide this over. So what are you getting when you divide it over? 0.99. Good. Now I have the sine of the angle is 0.99. How do I get rid of the sine? Inverse sine. How do you do inverse sine in your calculator? Second sine. 0.99. Yep, so because we're rounding, if I did second sine exactly, like if you keep the answer in your calculator, which these ones are the fancy calculators where you can go up and like highlight it, you don't have to actually copy it down. See how I get the exact same number if I don't round it? So then you get your angle again as 82 something. So either one would have worked. You see that you get the same answer. It might be a small decimal point off. That is not a big deal. We do not take off for that in here. Does that make sense? Okay, cool. Now number 2, we've got a fireman that is standing, I wrote over it, what is it, 50 meters away from a burning building? directs a stream of water from ground level at an angle of 30 degrees above the horizontal. The speed of the stream as it leaves the hose is 40 meters per second. So first let's draw a picture, because this 50 meters away from a building, would that be in the horizontal or the vertical direction? Horizontal, that's how far away the building is from the hose. So if this is your building, I'm 50 meters away, and you have some hose of water shooting up. Yes? Okay. As soon as you see the velocity at an angle, what can you do? Yep, find the VIX with the VI cosine and VI sine. So find the initial velocity for x and y. So I'm leading you through these problems today because they are trickier, but you still have to do all the solving on your own. I'm just giving you hints to set you up. So we would do 40 cosine of 30 and 40 sine of 30. What'd you get for the initial velocity for x? For x? Check your mode in your calculator. Yeah, it should be 34.64. If you're typing it incorrectly, check to make sure it's under green mode. And what'd you get for initial velocity for y? 20. What else can I put in my chart? Acceleration, for sure. Anything else? You can say that VF is 0. When is that true? At the top. So always true. Whether it will be useful, we'll decide in a minute. Anything else? Have I been given anything else? Distance. What distance do we have? 50 meters. Is that for x or y? That's x. Horizontal or sideways motion, that's x. So my distance is 50 meters. Now A is asking me for what? Time. Good. Now, I could use x equation to find time, or I could use y equation to find time, but only one of those is correct. Which one do I have to use here? Why do I have to use the x one? Yes. I want the time specifically to reach the building. Do I want the time to go to the top? No, I want the time it takes to reach the building that is 50 meters away. So you have to use the v equals d over t. You've got to use that 50 meters because that's where the building is, not at the top or at the very, very end. So plug in, find time, careful with your algebra here, actually write out your work. So we had to use 34.64. Why would I use 34.64, not 20? X, we do not mix and match. You're either using x values or you're using y values. We're using the x equation, so it's got to be consistent. X velocity, x distance. Now solving for t, if your unknown is on the bottom, what do you have to do first? Multiply by what? T. Good. You want to multiply the t up on both sides because then it crosses off on the bottom. And now I have t times this equals 50. Now what do I do? By what? 34. 34. Good. So take the extra second to multiply the t up because most people look and they just divide the 50 over, which is wrong. What'd you guys get for your t then? 1.44, good. Now we always label our time. Is this T up, T total, or neither one? It's neither one. It's the time to reach the building, right? That's not, I said or neither. I gave you that option. You guys are just shouting T up and T total. Think about, this is the path of a projectile, correct? It goes up and then it comes down. This would be the T up time. This would be the T total. Do you know where the building is in relation to that? No, you just know that that's the time it takes to go 50 meters. Let's go ahead and write this. This is the time to reach the building, which is why we used the V equals C over T. We did not use the VF equals VI plus AT because that would give me T up. I don't know if this is even on its way up or when it's on its way down. I just know that it's 50 meters away. Does that make sense? So it's not either, right? It's some random time to reach the building, which is what it asks for, the time to reach the building. Okay. B is asking at what height the stream of water will strike the building. So what are we looking for here? Distance for what? Y, because height is up and down. Good. Now, is this the maximum height? No. It's just the height at the 50 meters away. So it's not the very, very top. So will I use VF as 0? No. So this is true. The VF is 0 at the top. It's just not useful because I'm not asking about the top. I'm asking about the building, which is 50 meters away. So what would I use if I want to find the height at that point? What equation? Yep. V equals VIT plus 1/2 ET squared. You know your initial velocity. You know your acceleration. And see how we have the time it takes to reach the building? So if we plug in that time, we'll find the height at that time. Does that make sense? All right, plug in, find your Y distance. Alright, which VI would I use? 20, good. And we just said we would use the time it takes to reach the building. Do I know the A? Or the distance, sorry, not the A, we definitely know the A. Do I know the distance? No, we're plugging in to find that, so you can't put a number in. What'd you guys get for the height? 18.64, do we agree? Some people do. Alright, so that is the height at this point. That is not necessarily the maximum height, right? It could have been a little bit higher up than that originally, or it could be continuing on. We don't even know if it's on its way up or on its way down. So C is asking the total velocity that the water will strike the building with. If I want total velocity, what two things do I need to find the total velocity at some point? So VI is specifically at the beginning. Do I want the total velocity at the beginning? No, because initials like at the very, very start. I want the total velocity when? At the top? No. When?
When the water strikes the building.
When it strikes the building. So I want the total velocity at 1.44 seconds, correct? Okay, so in order to find total velocity, there's two things you need in order to find the total velocity at a point. What are the two things? The horizontal velocity and the vertical. So you need Vx and Vy at that point. Or I'll say at this time. Because once you have Vx and Vy at that time, how do you find total if you have Vx and Vy? hypotenuse. Yeah, Pythagorean theorem to find the hypotenuse, but yes. So we do this squared plus this squared equals the total velocity squared. Now one of those we already know. Which one do I already know? The x. What is the x velocity going to be at this point? Good. And why do I not need to calculate that? It's constant. It's not going to change. That's going to be the x velocity literally at any time, so I don't need to recalculate it. Do I know the y velocity at this time? No. That 20 is at the very beginning. I want to know the y velocity when it hits the building. What could I use to find the y velocity later on? Equals VI plus AT. Yeah. All right, go ahead and plug in. Are you going to plug in that VF equals 0? No, because I'm not talking about the top. I'm talking about this. What am I going to plug in that we had found earlier? Well, no, you don't need to plug this in. We're not using this. What time would I use? Yeah, the time it takes to reach the building, so we're asking at that time. So plug in using the 1.44, find the velocity after 1.44 seconds. What are you guys getting for the y velocity after 1.44 seconds? 5.88. So is this still on its way up, or is it already on its way down?
It's
definitely still on its way up. How do I know it's still on its way up? It's positive. Good. If it was on its way down, you would get a negative velocity. So this is like not even to its maximum height yet. So this is my y velocity. Am I done? No, I asked for a total, so do I just add them? Definitely not. So this is going over to the right and up. We know that we need to do the Pythagorean theorem, or the x squared plus the y squared, to get the total velocity squared. So plug in, find total velocity now. If you find your TF, 1.44 is less than that also. Right, so we do 34.64 squared plus 5.88 squared, and then what is your last step you need to remember to do here? Square root, because that's what B total is. So what did you get for B total? 30 point what? 35. Okay. 34.64 squared plus 5.88 squared, and then square root, you get 35.14? Okay. 35.14. I heard 30 point something. I was like, that's not right. Because see how your total has to be greater than these two? So that's a good check. Your answer had to be more than 34.64. We good? Okay, some of you are dying off. This is a day you want to follow along and do all of the practice. Alright, number 3, we have a place kipper. Places a football 36 meters from the goal. So let's draw a little picture. 36 meters from the goal, if this is your goal. And the ball must clear the crossbar, which is 3.05 meters high. When kicked, it leaves the ground with a speed of 20 meters per second and an angle of 53 degrees. So it's going over like this. And A is asking us, does the ball pass over the crossbar or does it pass under the crossbar? So let's think about, if I'm asking if it makes it over or if it makes it under, what am I really asking for? Like, what variable would I be asking for here? The distance for what? Y. I know the distance for x. What is the distance for x going to be? 36 meters. Now, some of you are sitting there like, yeah, but you know the distance for y. Do you know that the ball will pass exactly right here? No, I'm asking if it passes over or under. So what am I asking for? The distance for y. Because I'm asking, does it go above or does it go below? See how that's asking for the up and down distance? So when we make our chart, do we want to put this in as a known? No, that's how high the crossbar is. I want to know if it goes above or below. So this is not necessarily a known. It's just for us to compare. Is it above 3.05 or below 3.05? Is 36 a known? Yes. I'm asking at 36 meters away. So go ahead. I want you to, well, we can just do this together. 36 meters would go in for what? X distance. Good. And I can also put negative 9.8. And I was given what? Angle and velocity. So find your initial velocity for x and y.
What do you usually find first? I'll let you sit in my
What's your x initial velocity? 12.04. And for y? 16? Yeah, I have like 13.99, but yeah, that's fine. We'll use 16. All right, and we said, I need your focus, guys. We said end goal, we want to know the y distance, correct? Yes. If we want to use the, or find the y distance at this point, would I use that VF equals 0 at the top? No, VF does equal 0 at the top, but do I know that this is the very, very top? No, it could be on its way up or on its way down, so I'm not going to use that. Before we find the y distance, what do we usually have to find first? Time, yeah. You almost always have to find time first before you can find your distances, so what could I use to find time? The x, good. You can use v equals d over t to find the time, and then once you have that, then plug in and find your height. So you should be plugging into the v equals d over t to find your time right now.
Did you multiply the t? And then divide 12 over? Oh.
What are you guys getting for your t? It should be 2.99, or maybe you round it to 3 if you get 0.33. You did not multiply up and divide over correctly. Actually, write out your work, cross off things to get t by itself. Are we done?
No.
No, what are you looking for? Distance for y, what equation? Yep, this one. So plug in now, come on, focus. Focus, guys. You don't have to. Did you find? What did you find? You're saying because the distance is negative?
Negative.
No. What'd you guys get for your y distance? What did you get for dy, your y distance? 40 point something is way too big. Okay, let's do this together. 16 times 2.99 plus 1/2 of negative 9.8 times. So you should get 4.0 something?
Yeah.
Okay, so 4.0. Okay, so does it go over or under the crossbar? Over, because the crossbar was 3.05 meters high. If it's going up at 4 meters high, then it's definitely over the crossbar. Agreed? That was the purpose of finding the y height, is because I wanted to know, did it go above or below? We okay with this? Yeah. Alright, a lot of people are not paying attention. I cannot make you do the work. I cannot make you listen to me, but I can strongly encourage that today is the day you want to be paying attention and doing all the work with me. Do not turn and start talking to your neighbors. B is asking, does the ball approach the crossbar while rising or while falling? So a lot of you guys know, like, oh, is it positive or negative? Does the height tell me if it's rising or falling?
No.
No, what would tell me if it's rising or falling? What would be positive or negative? The velocity. You want to know the velocity at that time. That's what's going to tell you if it's rising or falling. Which velocity, x or y? Y. And what equation could we use to find the y velocity? F equals vi plus at. And what t would I use? The 2.99. So plug in, and then whether it's positive or negative, it will tell you if it's going up or down at that point. Yes, Ashley? This isn't until, no, it's the time to, it's a random time, right? It's it's not t up or t total. It's the distance to, or the time to that. Cool. What are you getting for your y velocity at this time? Somebody. Marissa, I see it in your calculator. What'd you get?
I got negative 13.8.
Good. So, is it rising or falling at this point? Falling. And how do you know it's falling? Because you have a negative velocity. Negative means that it's going down at this point. You also could have a different way to do this, is you could have found what T up is. So if you plug in, you get that VF is 0, TF is 1.6. That's more than that, so it's on its way down. We okay? Alright, cool. Number 4, so we have a football kicked at an angle, reaches a maximum height of 4. How far away did the ball land? So first, make your chart, put anything that you can in your chart right now. Alright, these 4 meters, where'd go where? Y distance, good, and I know acceleration. And a lot of you put VF is 0 at the top, that's good, that is always true. Let's think through, is that useful here? It is useful. What keyword tells me this is useful here? Maximum height. Maximum height is at the very top. So see how the 4 meters would go at the top?
Yep.
So the reason it was not useful before is because it was some X distance away. It wasn't at the very top. Do you see this relationship? Okay. Alright, good. Now, I gave you some hints. I'm asking you to find VIY first. So what equation could I use to find the initial velocity for Y? VI cosine and VI sine, yeah, but do I have VI?
No.
So I can't plug into VI sine if I don't have VI. So what else could I use? Look at your chart. VF equals VI plus AT. Is that going to work here? No, because you don't have sine. The VF squared. Yep, just try everyone until she stops saying no. No, plug in, find initial velocity, and the reason why is because you have the VF and the distance. Right, so we should have plugged in the 2 times 9.8 times 4 is 78.4, added over, and then what? Square root. So what'd you get for initial velocity? Good. Is that my total initial velocity, just x or just y? Just y, because we use the y equation, we use all y variables. See how that's initial velocity for y is 8.85? Alright, now we can put it in our chart. Now, in the hint, I also told you, what else do you find? What next? Time. What could I use to find time? Good. VF equals VI plus AT. So find your time. What'd you guys get for your T then? 0.9, good. And what time is that? Is that T up, T total, or neither? That is T up. And how do we know for sure that is T up? Yes, we use VF is 0, and that is true at the top. It doesn't tell me like which time it's asking for, so let's just find both. What would be the total time in the air then? 1.8, good. So we have initial y velocity, you've got T up, you've got T total. We can go ahead and put that in our charts. Next thing is asking us to find what? We found this, what else? Before you can find VIX, you have to find the VI, the total VI, yes? So what have we been given that we haven't used yet? The degree, the angle. So what equation do you think we're going to be using to find the VI? Yes, the VIY is the VI sine. How come I'm using this one and not the VIX one? Because you don't have VIX, right? But I do have VIY, yes? And I do have the angle, so plug in, substitute in right now. biggest mistake people make here is they put the 8.85 here. 8.85 is the initial velocity for y, not the vi. I'm looking for the vi. So does it make sense why this would have to go right here, not inside? So that's why labeling is super important. That is the initial velocity for y, so it goes in for initial velocity for y. I'm not doing any like crazy thinking. I'm literally just labeling it, and then you put it where it says that. Yes? Now here, most of you guys are scared of sine, so sine of 40 is just a number, so let's just put that in our calculator. Sine of 40 degrees. What is sine of 40 degrees? 0.64, so this is just 0.64 VI. And now it should be easy to get VI by itself, so solve for the total initial velocity. So what did you guys get for VI when you divide this over? Yep, 13.76. Good. Now let's talk